How we climb.
Oh yeah.
Wow, no need.
Okay, it is time to begin here. And I see everyone here except for Caleb and Tioni. I am not sure why nothing is showing up there as far as my presentation. But I'm going to go out on a limb and say that something has gone afoul because it won't go up there. So I'm going to do the hardwire connection now rather than risk problems later.
So do we get to watch the video today?
Video?
The video? Yeah, what?
Sorry, wrong class.
Yeah.
Oh, let's watch a video. You can't be excited.
No. Yes. What was that? There is, and we will watch a Simpson video eventually. Okay. There we have the presentation showing. So we're going to talk today about Mars, asteroids, and comparative planetology. For people who may not have figured out the theme here, today is October 21, 2015, the date at which Back to the Future went to the future in 2000, or in the Back to the Future 2, and they were wearing two ties. That is the predicted vogue for today. Hence, had to fit in. Okay. No, that was back in 85 or 86, whenever it came out. So we're going to talk about Mars and asteroids today. So Mars, here's a beautiful picture of Mars. Oh, there it is. What do you notice when you look at this picture of Mars?
It has blue around it. It has ice on the bottom.
Okay, has blue around it is the first thing I heard. What does that tell you?
Atmosphere.
Okay, there must be some atmosphere causing that blue. It's Rayleigh scattering. Okay, so that's the first thing. It has some small atmosphere. What was the next thing we had over here?
Ice on the bottom.
Okay.
Well, it looks like ice.
There is
Polar ice cap.
a polar ice cap. So there are polar ice caps on Mars just like we have polar ice caps on Earth. What's a third thing you notice?
I see like an angry ape face. Nobody else?
That's weird because I see Mr. Moose from Captain Kangaroo.
It's red.
It's red. That's what I was looking for. It's red. And we've already talked about this, I think. What's the reason it's red?
Oxidized iron.
Oxidized iron. It's basically the color of rust because it's got the iron there that's been oxidized. So we know a lot about Mars. We have spent enormous sums of money as a human race sending things out there to examine Mars. And so, we have like the Mars Reconnaissance Orbiter. We'll talk a little bit about that later on today. We have the rovers up there, Spirit, Opportunity, Pathfinder. Lots of things have been sent up to Mars to study it. So we know quite a bit about it.
So it's smaller than Earth.
It is smaller than Earth. Was that a question or was that just a statement? Okay. Yeah. Here is a map of Mars. Now I look at this map and I see some really cool features. For instance, I noticed Hellas Planitia. I assume that's how you pronounce Planitia. What do you suppose that means? Let's notice that we have contrasting Utopia Planitia.
Big low spot.
Okay, well the Hellas
Terrible
Hotel-
spot, really great spot.
No, the utopian, I don't know what Planitia stands for. I'm going to guess like planet or world or space. So the good space and then the hell space.
That's what one would think. That's not the truth, though.
Okay.
I mean, that's what I thought, too, and I looked it up so I would know rather than give you false information, because that's what I would have guessed. This is the nowhere plane. Or, yeah.
The nowhere plane, really?
Yeah. Utopia apparently means nowhere. There is no perfect place, right? We always think utopia is perfect place. Apparently it means nowhere. So that's the nowhere plane. And Hellas, if I tell you it's the same root as Hellenistic, will that help you out?
Yeah. So the motherland.
Well, if you're Greek. Right, because I have always looked at that and just said, oh, it's heaven and hell. Right? It just seems like that's what those are supposed to be. Heaven will be perfect, and we think of utopia as perfect, and hell is the opposite. But it's not the case. So it's like the nowhere plane. It's because there's virtually no features there. And then the Hellas Planitia, because it was a big enough feature that people were able to see that in early studies of Mars. And they say, hey, the Greek, no, that's us. That's our place. Now, that's pretty much the boring side. If you look at this, the colors are false. The blues are lower elevations because on Earth the lower elevations are filled in with water. Hence, those are the places that one would expect to be oceans if there was a similar amount of water on Mars, percentage-wise, as there is on Earth. The highlands are in the redder colors. This side here has the real interesting features. Notice you have this feature here, going from there to, I don't know, somewhere around here. Valles Marineris. It's not anything to do with spaghetti. It's everything to do with the Mariner spacecraft. It's the Mariner Valley because it's named after the spacecraft that discovered it. That is the biggest canyon in the solar system. I almost said on Earth, which would have been ridiculous. It's the size of the United States.
Well, that's pretty cool.
It's a pretty, I consider, as Labor said, this is smaller than Earth. And yet it has this big old canyon that's bigger than the entire United States.
Speaking aggregate or
That's the length. It's also, I forget, I didn't look up the depth, but it's also much deeper than the Grand Canyon. So it dwarfs our biggest canyon on Earth.
So it goes from -7 kilometers to like.
You have a total elevation change of 21 kilometers.
Okay.
And so what they consider to be where sea level would be is the one that's marked 0 kilometers.
You even have a mountain that's larger than Mount Everest.
Right. The tallest mountain in the solar system is right here. Olympus Mons, Mount Olympus. The home of the gods, if I am not mistaken. I should look to Laborth. I'm sure he can tell me. Mount Olympus is the home of the gods, right?
Yes.
Yes.
Okay. Just making sure. He apparently knows all the mythology, so I turned to him.
You too.
You do too?
Yeah.
Do you guys all take a mythology class?
Yeah.
No.
Usually when you're in middle school, you take mythology from several different cultures. Now, if you went to an Adventist institution, likely not.
Yes, we did not learn any mythology. Okay, so we've got some cool things. The tallest mountain, the biggest valley, the biggest gash in a planet. And they're here on this region that's called the Tharsis Bulge. The Tharsis Bulge is a region that has bulged up. And that's where most of your interesting things are on Mars. You see that Olympus Mons is not the only big volcanic mountain there in the region. So there's some interesting features here to see on Mars. Now let's go through and look at some of these specifically. But first, the clicker question that actually I think it's first. Yeah. What does Hellas Planitia mean?
Awesome.
By the way, everybody knows San Francisco. Do you know what its original name was?
Was it San Hel?
Wasn't that named after Francisco Pizarro?
Death Valley.
Yerba Buena. I did a little harbor cruise with my sister, and the guy who's giving the cruise says, yes, San Francisco was originally known as Great Weed.
Oh my.
Yerba Buena just means mint.
Hey, that's what he told me, that Yerba
Looks like
was weed. I don't speak. Eliezer?
Yes. I'm trying to switch my channel out from 32 to 6. Oh, yes, it is 32. Just kidding.
Very awesome talent.
There we go. Okay, so we have 1, 0, 11, 1. I'm going to assume that the person who said awesome planet was just having fun. Worried about the person who said very hot place. Remember, what did Hellas mean? Greek. It's the Greek plane, as in Hellenistic culture. Don't want you to answer that one yet. All right, so moving forward, I am tethered. I can't walk around and stand in front of you, which makes me sad. So here's a picture, a little better picture of that Valles Marineris.
So is that digitized or a real photo?
It's a real photograph.
That looks epic. We don't play.
Can we go play? Absolutely. We can totally live on Mars, right? What do we need to live? Oxygen. Yeah, we need some water.
Does gravity help?
Relatively high temperatures. Well, it does have a high enough gravity. We would be fragile bone, but yeah, it doesn't have the oxygen we need. It doesn't have the warm enough temperatures that we need.
More gravity?
Well, no, that wouldn't be a problem. We'd just be good jumpers
Oh.
until our bodies weakened.
We'd be super weak.
Yeah, we would over time become very weak, but So no, we can't live there. In other words, despite what you might see in movies, I re-recorded off of HBO this week because they had free HBO weekend, Mission to Mars. And if I remember right, that's the one where the guy basically is living in a greenhouse on Mars. Even if you had 100% oxygen inside of that greenhouse, the atmosphere on Mars, this is coming up in a few slides, but the atmosphere on Mars is like 0.6% as thick as the atmosphere on Earth. If it was 100% oxygen, you would still just straight up suffocate. And in a greenhouse, you have the same pressure inside now. It's not like it's pressurized oxygen. Couldn't happen, but hey.
What about Total Recall?
Hey, they did this.
Total Recall is very funny because the pressure goes from can't tolerate because it's so low to high pressure in no time. I mean, their eyes are bugging out, and then all of a sudden, hey, we're all good. It's kind of funny, but not very realistic. And that's, of course, the good Total Recall, not the lame one.
Are you talking about
The-
the old one or the new?
Just don't waste your time watching.
The original one was I thought pretty good. The remake was kind of silly. Like they go through the Earth. Now, if you go through the Earth, you guys have had enough from astronomy class. Do you see any problems with going straight through the center of the Earth?
Many problems.
Okay, really hot, really hot. That whole melting thing would probably concern you. Also, you'd be going through that geodynamo, which might be problematic. And
The third one would be the gravity. The closer you get to the envelope or whatever.
if you were to look at the acceleration of gravity, on one side of the Earth, okay, it goes, something like this, and then it would just go like this. The reason for the change in direction is, of course, because it always points down. It would change linearly as you go through the Earth. So as you were going down toward the center, you'd just get lighter and lighter and lighter until when you get to the center, you'd be floating, and then you'd get heavier and heavier and heavier going the other way. What happens in that remake movie?
Nothing.
No, something.
They get lighter. Or they get,
They stay normal until they get to the middle point, and then they go wham and slam over to the other side. So in that movie, the gravity essentially was like that instead. You stay at full gravity until you get to the center, and then wham, it switches to the other side. It's like they didn't even try. Jules Verne, I think it was, wrote a book about a mission to the moon, and he figured at some point you'd have to get to where the gravity is stronger pulling you toward the moon than pulling to the Earth. And he had the same type of idea that you would slam from one side to the other when you reach that point. So the people who made the remake of Total Recall were no better in science than Jules Verne was back in his day. Okay, sticking with the topic of the day, Mars. Total Recall, totally about Mars. The tallest mountain in the solar system, I would say universe, but of course that would be incorrect. Very solar system centric, is Olympus Mons. It's the tallest mountain in the solar system. This graphic here shows the tallest mountains, not all of them, the tallest ones that we think about. There are other taller mountains than any mountains on Earth that are not listed here. So we have Olympus Mons, 81,100 feet. I don't know why it's in feet. very tall mountain. Notice it's a volcanic mountain. It was created by volcanoes. Next tallest mountain in this graphic here, Maxwell Montes. What planet is Maxwell Montes on? Venus, right. It's one of the male names on the female planet. Or maybe it's neuter. I don't know if Maxwell actually has a gender, does it? Probably not. It's probably a neutral name. Then we have the tallest mountain on Earth. What's the tallest mountain on Earth?
Mount Everest.
K2. Apparently Mauna Kea.
Yes. Mauna Kea is the tallest mountain on Earth. Most people don't know that. Why? Because the highest elevation on Earth is the top of Mount Everest. And so then you have what seems like a dichotomy. How can the tallest mountain not be the highest elevation? Where is the base of Mauna Kea? It's in the ocean. So Mauna Kea starts below sea level. It's the tallest mountain from the base of the mountain to its peak on Earth. But because Everest starts at a higher elevation, even though it's not as tall, it reaches a higher elevation. Yes, ma'am?
How does that compare to a mountain that starts in the depth of the Marianas Trench?
I don't know a mountain that starts in the bottom of the Marianas Trench,
There is in Guam.
but I do know that Mauna Kea is still the tallest mountain from base to top. Notice that Mauna Kea, like Olympus Mons, is a volcanic mountain. And in fact, both of these are what we call shield volcanoes. When you think of a volcano, what's the shape you think of for a volcano?
Usually we think
of
of
a crater.
We think of a cinder cone and then having a crater in the center. So what we usually think of, let me get rid of this useless work. What we usually think of for a volcano is something that looks something like this. You know, like the Brady Bunch volcano, right? And then you have magma that comes out and goes, flies up everywhere. That's a pyroclastic eruption. That kind of volcano has to have magma that doesn't flow very well. Magma that can kind of plug it up and build up a gas pressure behind it and then has a very violent explosion. And that violent explosion throws all kinds of stuff up into the air that falls down and creates that cinder cone. That is not the kind of volcanoes that we see in Hawaii or that we see on Mars. The ones we see on Mars and Hawaii are much smoother. They're created by magma that just comes up, bubbles out, and flows down. And we call those shield volcanoes because they tend to have a shape similar to the shape of a shield that you might have if you were, a Viking warrior. So these are shield volcanoes, magma that flows rather than not flowing. One of the really interesting things, at least to me, about Olympus Mons is that Olympus Mons, being such a huge, huge mountain, very, very heavy, if you go down to the edges of Olympus Mons, it just sits there on the top of the planet. If you take Mauna Kea, you get down to the bottom of Mauna Kea, and it's sunken. Nice, I just spit on my tablet. Mauna Kea has sunken into the ocean floor. So it has essentially a moat around the mountain because the mountain is so heavy that it's pushed down into the earth. So you can see a difference here. A not as heavy mountain on Earth, even with Earth's stronger gravity, it's still not as heavy, has sunk into the earth because it's so heavy. A heavier mountain on Mars hasn't. That suggests that Mars must have a much stronger or harder crust than the Earth does. Notice the age, 250 million years old. I got quite the tongue lashing last night talking to my wife. Same difference when it comes to this topic about long ages. She said, well, it can't be. Scientifically, that's what science believes based on scientific measurements. And theologically, some people come to different conclusions. And in this class, I'm teaching you what science says. You don't have to believe that the Earth is this old, that the Mars is this old. But you do need to know that that's how the scientists figure it. Well, the way they get the ages is from things like radiometric dating. Now, for getting the age of Olympus Mons, it's not going to be radiometric dating. It's going to be looking at things like erosion and trying to calculate how long a surface could have been with the erosion they see.
I'm just kind of guessing.
Another,
Guessing with, like, from the evidence.
it's not blind guessing.
Right.
Yeah. Another interesting feature on Mars is sand dunes. It has these fields of sand dunes. I mean, you might as well be out in the Mojave Desert or something with that. Blown around by the winds. They're in the mid-latitudes. On Earth, our deserts tend to be around 30 degrees north and south because of the convection currents taking hot, moist air up at the equator, bringing it over and dropping it about 30 degrees north and south as dry, hot air. So, similar idea here for where you have the deserts on Mars. And finally, finally for this segment, the polar ice caps. Mars is tilted 25 degrees. Do you remember how much the Earth is tilted? That is
2.3.
23.5. That is the tilt of the axis of rotation compared to its orbit. We're tilted 23.5 degrees. What happens on Earth because of that tilt? We have seasons. When the sun, when we're tilted toward the sun, that's summer. When we're tilted away from the sun, that's winter. And we have the polar ice caps because you have regions that are like in shadow for a stretch of time, so they don't get any solar radiation. It gets colder and colder. So we have the same thing on Mars. But of course, Mars is special. It doesn't have the water we have. You guys are goofy. It doesn't have the water we have, so its polar caps are largely carbon dioxide covered. Now, notice here it says composed mostly of water ice covered by carbon dioxide. What do we call carbon dioxide ice on Earth?
We call it dry ice.
We call it dry ice. So the cover of those polar caps is dry ice. Underneath, believed to be water, I say believed to be, spectroscopic measurements looking at the absorption spectra, they can determine that they must have water under there. Okay, now our next question. What is the tallest mountain in the solar system? So we had Olympus Mons. Which one is the tallest mountain on Earth?
That is Mount.
Mauna Kea. That's tallest on Earth. But of course, the highest elevation on Earth is Mount Everest. One of the things I didn't point out on Olympus Mons, it's so tall that it's above most of the atmosphere on Mars. How crazy is that to have a mountain that'll take you out of the atmosphere? It's almost like you think about the biblical story of the Tower of Babel.
That's pretty epic.
It's kind of like that. This is a mountain that takes them up above. Okay, water on Mars. We had the announcement, and I'm going to have a slide relating to that announcement, about water on Mars recently. Well, most scientists believe that in the past there has been liquid water flowing over the surface of Mars. Why do they believe that? They have things that look like dry riverbeds, things that look like splash craters. That is like, imagine that you have a dusty surface and you dump water on it. You dump the water on, you have the water splashes, and it makes a fairly unique pattern. And they have features that have been seen on Mars that look like that. And you have gullies and crater walls, and you have salts, chemicals, that are only known on Earth to exist in aqueous, that is, we only make them in aqueous solutions. So they would have to be made in water. On Earth, we say, well, it must have been the same thing there in Mars. So Mars would have to been quite a bit different to have liquid water on its surface than what it is today. It would have to be warmer, and you have to have a denser atmosphere. Now let's look quickly at some of the evidence from Mars. So I just have pictures here. This here shows what looks like water flow patterns. So it looks like water's been going like that, right? So it kind of looks like water's been flowing there. Here we have things that look more reminiscent of ice flows, and I know ice flows is spelled differently than flow of water. We have here things that look like splash craters. See this action out here? That looks like you had some kind of liquid stuff that splashed out. And then we have, I believe this is the new, gullies. Okay, these here are the gullies. Clearly that looks like gullies formed by water on Earth. This has got to be, okay, this is the new one. This is the basis for the announcement that was most recently made in September about water on Mars. And so what I want to do is to make sure we understand what they announced and what they didn't announce. So what they announced is that they saw, and this actually was first observed in 2000 when the guy who made the announcement was an undergraduate, that you have these things here.
Is that Mars?
This is on the surface of Mars, yes. You see it.
Lots of snow there.
Actually, it's not snow here. It's false color. Where I took this from was from a NASA webpage. It described how they got this. But that thing that I drew, and you see lots of those things, these are the same things here. You have these brown things. And those brown things show seasonal growth and ebbing. So they come and appear, and then they disappear. And when they appear and they examine them, they see that they have hydrated perchlorate salts. So they say there must be water there, and the water is what's making those. And then when the season goes to a dry season, well, actually, when it goes to cold, so that you can't have liquid water, then it disappears. So they said there must be water on Mars. That's what's been discovered. They haven't seen flowing water. And in fact, they posit that there must be water that's flowing somewhere underneath the surface of Mars, but close enough that it can seep out to cause this. Now, the temperatures when they see this are still well below freezing temperature for normal water. So it'd have to be a very briny solution, a very salty solution to be able to be liquid at those temperatures still. So it's not pure, clear water, as the song goes. Yeah, not drinking water, but at least liquid with H2O in it that's below the surface. So this is the evidence, seeing these things grow and shrink seasonally, and looking at the absorption, or actually reflection spectra in this case, looking at the spectra from these to identify the chemical components and saying, we have a hydrated salt there that's appearing and disappearing. So, and yes, here's the technical name, recurring slope lineae. In other words, recurring lines on the sides of hills. Yeah. So, question, have we detected flowing water on Mars?
I feel like that's a tricky word.
No, that's a very straightforward wording.
You mean water as an
Have we
example?
seen like a river or a stream or even a rivulet of water flowing on Mars?
Like liquid water?
Yes, liquid water. Okay. I'm telling you, I think there's just one person who wants to answer contrary every time. The correct answer is no. We haven't seen flowing water. We have seen evidence for water flowing under the surface. We have seen evidence that there has been water in the past, but we still haven't seen flowing water. And remember, no matter what Dan Quayle said, even if we find liquid water, that doesn't mean we can live on Mars. That was...
Well, isn't he once the vice president of the United
Yes, he was. And it was as vice president that he said...
Under George H.W. Bush.
He was vice president under... Yes, Bush. So, if we haven't found liquid water flowing on Mars, and there used to be liquid water flowing on Mars, where is it?
It's left the atmosphere.
Good answers all. Some must be trapped beneath the surface as permafrost, frozen. Some locked up in mineral compounds. Some evaporated from the surface, he said. And some broken apart to make just hydrogen and oxygen, with the hydrogen escaping. So it could have had a lot more water in the past and lost a lot of it or frozen a lot of it. But what we can say now is it still is very dry. We don't see liquid water flowing.
So what's the theory that Mars became so lifeless?
I'm not prepared to talk about that today. That is, I haven't done any recent study on that. But the short of it is that Mars has a low enough mass that the escape velocity is low enough that even gases like water could escape from it. So it couldn't hold on to them. So while it had them in the past, it's lost them now. And if that's the case, then if we replenish them, that would be a short-term solution because eventually they'd be lost again.
So we need to make a giant Mars-sized dome.
Yes, we need to make a big dome over the entire thing. I'll put you in charge.
Or terraform the planet?
But the problem with terraforming the planet, you create the gases, but then the gases are eventually going to be lost. So you have to continue to create the gases, but where do you get the molecules, the atoms?
I have another idea.
Fire away.
We smashed a comet.
This has been suggested.
Two comets.
This is not a joke. This has been
No,
suggested.
because we could slingshot it using gravity to just slingshot one or more. Well, it would be kind of hard to get a hold of, but one or more comets and hit them. We'd have to time this just right because if we move Mars a little awkwardly, we can either lose its orbit or it can come hurtling at us.
But this is a seriously suggested idea. If we can redirect a comet so that it hits Mars, then we could have a temporary atmosphere and maybe have it habitable for some time period. And then just get another one to hit it. Yes, Meg.
Who thought it would be a good idea to mess with something that they don't even understand completely themselves?
That's what we do with everything. We're humans.
We have played God several times.
Increase the gravity on Mars. That's the proposition.
Well, no, you can't increase the gravity. That requires increasing the mass significantly. Seth.
Okay, so sorry, I guess I just missed a couple of pieces. But how would smashing a comet into Mars?
Comets are made up of ices,
Right.
largely. Not completely. There's rock in them, too.
Right.
And so you have these ices. You have things like water ice, methane ice, and whatnot. Those are things that are going to form an atmosphere on a planet. And so you crash it in, you bring the molecules. Yeah, they would have to melt. And of course, during the collision, they'd be broken up into tiny things that get dispersed all through the atmosphere. And then you have a greenhouse effect that's going to cause the surface to warm and hopefully keep them liquid.
We just snap another planet into Mars so it becomes the size of two planets.
Good plan. No, we can't.
How are they even just manipulating the orbits of like comets and stuff? Because you're gonna have to put planets
Yeah.
and stuff like that.
You're going to have to.
You can hit a comet and deviate its course.
Yeah. You're going to have to send a rocket to a comet. And, I mean, if we're going to try something crazy, we can send something out there just into the Oort cloud, find a convenient object, and then redirect it with just the right amount of rocket thrust so that its orbit.
About 5,000 years.
Yeah, I know.
And then 3,000 whopping eons later, we'll have water on Mars.
Then
Yes.
in 5,000 years, someone will wear 2 ties.
Easy now.
We thought it would be like.
Easy. Okay, let's get back on topic. So Mars' surface, here's some pictures that are better pictures of the surface. I'm not going to show you pictures of a spoon or, the...
Dude, I want to see the spoon though.
I am sorry. I should have thought and found these pictures of... I can't think of what the other things are, but there's a number of things people say. It was there and then it's gone. Somebody came and moved it. There are true believers out there. What was that?
There is wind on Mars.
There is wind on Mars,
It
yes.
is very fast, isn't it?
The winds are normally similar to ours, but when they have a storm, yes, it gets very, very fast. So I guess it's not on this slide. I have a slide, I think, that has those numbers. I know I read them when I was preparing at the very least. Here I have that the winds are gentle typically. You have no rain, but you do have dry ice snows.
Whoa.
Well, we do too. Some of your fire extinguishers are CO2 fire extinguishers.
Yes,
you take
this
this.
happens naturally.
You take the CO2 fire extinguisher, and you point at your friend, and you pull the handle, and it snows on them. Just like being on Mars during a snowstorm. When I was in high school, my physics teacher took one of those and put it on the desk and took it off, and there's just a pile of dry ice snow. It was pretty cool. I found an old fire extinguisher and tried playing with it, but it was a powder fire extinguisher, and they're not nearly as fun. Okay, temperatures. The highest temperature on Mars is about 20 degrees Celsius, which is room temperature. About what it is in here right now. It's about as hot as it gets on Mars. If it was like that year-round, I'd be totally okay with that. The problem is the downside, that minus 153 degrees Celsius. Yeah.
So wouldn't, if we created a greenhouse effect on Mars, wouldn't that actually raise that high temperature quite high?
Yeah. Well, it would raise it higher. Having the atmosphere actually causes an equilibration of the temperature, so you don't have as big of extremes. You get closer and closer to the average. So the atmosphere would actually probably initially make it so it doesn't get as hot, but it would make the cooler regions come much warmer. And, if you get enough atmosphere, then you can get it back to
So
where.
if we could create an atmosphere on Mars, it would be basically perfect for our body temperature.
I don't have enough knowledge to answer that question. Excuse me. I'm sorry, but I just don't.
Can't we have a rotating thing that always stays within that one, within the area that's nice and warm? Like a train that,
Even though it's nice and warm, it's still not hospitable. Because, for instance, you couldn't breathe. That's generally not viewed as a good thing. Okay, so here's the question. This is a multiple answer. Answer all the ones you think are correct and hit enter. Is Mars a place where humans could live in Earth-like houses? Houses that have windows and doors.
You said this is multiple answers?
Yes. Which means that the answer is not A or H.
Well, you just ruined my answer. I wish you wouldn't have said anything.
Well, just applying logic here. If it's more than one, if it's more than one, it's got to be no, right? Because it's the only answer that has more than one.
Are there any proposals on the committee of sending the first man on Mars?
There are plenty of proposals. I don't know if any of them are taken seriously. Okay. Nobody said this one. One person said this one. To his credit, he said it before I said it couldn't be that one. 0, 12, 9, 4, 12, 1. I did not understand that.
I said, don't put the blame on me.
Oh, okay. So, let's look at these. Too hot. One person, I tell you, is that one person who's just out to make me believe I'm not teaching anything. It is not too hot. The highest temperature it gets on Mars is what? About 20 degrees Celsius, or about the same temperature it is in this room right now. That's not too hot for human life. But its coldest temperature, minus 153 Celsius. That's too cold. So that was the correct answer. Pressure too high. No, 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 no. Remember, it's 0.6% of Earth's pressure. So, yeah, that's not too high. That's too low. We actually rely on the air pressure for breathing. When you breathe, you tend to think, yes, I pull air in, I push it out, right? False. What you do when you breathe is you push air out, and then you let the air pressure push it back into you. So you can't pull air in. All you can do is push it out. And, well, yeah, that's also true. And so if you don't have that air pressure to push air into you, it's not going to happen. And 0.6% of Earth's pressure is not going to be enough for you to breathe. So, pressure too high was false. Pressure too low was true. Not enough oxygen, definitely true. What's the majority gas on Mars?
Carbon dioxide.
Yeah, that doesn't help us. Too much oxygen. Thankfully, no one said too much oxygen. Okay, so there were 3 answers that I consider correct there, and those were the 3 top vote getters. So, kudos to people who answered those.
I would have answered something wrong. I would have answered
How many people have seen the face on Mars? You all have now. This here is the face on Mars. It's on the Tharsis bulge. Now, if you look at that, does that look like a human face? Yeah, it does. And so, how big is it? Oh, it's really big. This is an early picture. And it looked enough like a human face that even NASA said, we need to explore this. Because, I mean, if it's a human face, then, well, there must have been some intelligent life that made this, right? And so they went back, and I am not going to the web pages, but you can see I have these little links down here. If you go to those links, which are all on the same website, you see different images NASA has taken when they came back and had higher resolution. And what you find is it's just a normal mountain. And that's an artifact of the way the sun was shining that day. It's not a mountain that is actually shaped like a face. And so, yeah, that's disappointing, especially to the people who want to believe in alien life. Now, I talk about people who want to believe in alien life. As a creationist, I believe God created life on this earth. I don't have any time issues on how long it took for life to develop. But if you believe in evolution, it would have to take an enormously long time for life to develop. Now, the most recent thing I read said that life evolved 4.1 billion years ago on Earth, based on some pretty shady evidence. That still really doesn't give enough time for evolution, as scientists understand it, to get to us. And so there's some time issues. There's just not enough time for evolution to occur. But if you could have had life start somewhere else and develop and then get to Earth, well, then you have a better chance of evolution actually, being legit. And so there's a lot of desire to find evidence of life coming to Earth from somewhere else, because that helps the timeline for people who believe in evolution. Now, the people who think this is an intelligent made structure tend to be a little on the the goofy side, we should say. They also believe that they see nearby a town because there's a bunch of kind of pyramid-shaped features. They say, that's their homes and the temple, and they got it all planned out. Yeah, I don't buy it. Maybe I shouldn't be so dismissive of them. The moons of Mars. Mars has 2 moons, Fear and Terror, or Phobos and Deimos. Those moons look exactly like the Earth's moon, right?
No.
Yes.
Look like asteroids.
They look like asteroids. They don't look like the Earth's moon at all. The Earth's moon has enough mass that gravity forced it into the shape of the sphere. Remember, that was step 1 for something to be considered a planet, was it had to have enough mass for gravity to form it into a sphere. These clearly don't have enough mass for gravity to have formed it into a sphere. So they don't look anything like our moon. And notice both are small, less than 20 kilometers across. So, like the size of Lincoln, maybe?
I was going to say Nebraska, but yeah.
I'm not going to go anywhere there. Okay, so we're talking some pretty small rocks, really, in the global scheme of things. Now, they're large compared to, the biggest granitic monolith on Earth is El Capitan, and El Capitan is very tiny compared to these. But they're kind of small. Phobos is, notice my language, it's twin brother. 7 times more massive than its twin brother. They're almost identical twins.
They're both the sons of Mars.
I did not know that.
Or Ares. Phobos and Deimos, they're sons of Mars or Ares.
Which makes perfect sense then for them to be moons around Mars, right? But they are essentially asteroids. So where did they come from? What was the theory on where the Earth's moon came from?
It came from an impact.
Right. Is that the only impact we think has happened in planets?
No.
Name some others.
Well, we had an impact with Mercury. We had an impact probably with Venus because of its retrograde spin.
Evidence for those?
Yes. Evidence for Venus is we have the retrograde spin and lack of magnetic field.
Okay.
And then we have Mercury, which has, I don't remember how we came to this conclusion, but it has a really large core.
Right. It has a much higher, because its density is almost the same as the density of Earth, but it doesn't have nearly the mass, so it can't be crushed as much by gravity. That means that it must have a higher percentage of high-density material, i.e. iron. And so they say it must have a much bigger iron core, but how does it have a much bigger iron core? It doesn't make sense because it should have collected iron and silicates with the same efficiency the Earth did. And so the theory is it must have formed with a big crust, commensurate with its core, and then had a big collision that knocked a huge amount of the crust off of it, and it's lost that, and so it has a bigger percentage as the core because it lost a lot of its crust.
What is it?
And mantle, I should say.
Then is it Uranus or is it Neptune that has the
Uranus.
side spin?
Uranus is outside. We haven't gotten there yet, so I wasn't expecting that one to come up. But we have a number of things that we believe are the result of major impacts in the solar system. These here are the types of objects that might be impacting things.
Those are the troublemakers.
But instead of impacting Mars, they just got too close and got collected up. They got close and Mars' gravity just held on to them.
Feels like stop it.
Okay, the asteroid belt. The asteroids are primarily in the asteroid belt, but not completely in the asteroid belt. So here we see a map of 21,785 asteroids. Notice there are 21,785 located in the asteroid belt, and it's estimated there are 750,000 actually there. So it's estimated there's a lot more. We just can't measure them all. Only 200 larger than 100 kilometers in size. How large is 100 kilometers? Like from here to Omaha. So they believe there's only about 200 total asteroids that are the size, diameter equal from here to Omaha. So not very many big ones. Most of them are small ones. If you think about mining the asteroids, there's not going to be that much to mine on each one because they're relatively small. Now, I'll grant you, if you had an asteroid that was the size of going from here to Omaha, and it was all made out of something useful, well, that would be a significant amount of material.
Gold.
But it's not that useful. When you look at this picture, how close do the asteroids look?
Very close.
They look very close, but that's because the size is exaggerated.
Yes, that's right. They look very close. So when you go to Disneyland and you ride Star Tours and they go through the asteroid field, or is it a minefield?
It was the asteroid.
We see both things showing up. It's like, well, you got to do all the zigging and zagging to avoid them. No, there's a lot more empty space than there are asteroids, so you wouldn't be having to zig and zag. So if you put all the asteroids together, you have about 1% the mass of the Earth. That is, if it was all clumped together in one object, it'd be too small to be a real planet. So it's not likely that the asteroid belt was a planet that broke up. The theory is that you had a protoplanet, something that was developing and might have eventually grabbed enough material to become a planet, and then it was torn apart either by an impact or just by gravitational forces to give you these asteroids. Now, you notice Earth's orbit. Earth is this aqua-colored planet, the orbit of the aqua-colored thing. There are asteroids that are in our region and that are closer to the sun than us. Not many, but there are some. Most of the asteroids are in this belt that's between Jupiter and Mars. And then there's some asteroids here that are called the Trojans that are co-located, if you will, with Jupiter. They are in a position where they just orbit with Jupiter.
Now,
So the asteroids aren't far enough distance not to be sucked by Jupiter.
Yeah, they're at places we call the Lagrangian points that are stable and won't get pulled in.
so these haven't been cleared up by Jupiter yet.
Well, they actually are kind of collected by Jupiter there. Now, yes, they haven't been cleared out, they've been collected.
'Cause I remember
But the
there was
key is
classification.
the mass of Jupiter. Just think about it. The mass of all of the asteroids is less than one, or is about 1% the mass of Earth. You take Jupiter, that's so much more massive than us. The mass of these asteroids compared to the mass of Jupiter is minuscule, and that's what they use for the comparison: is the mass of the material you're sharing the orbit with compared to your mass. So it easily dominates its region. Okay. Oh shoot, I'm out of time. I am so, well, looks like these slides didn't come through anyway. I don't know what's wrong, but I guess we stop here because the slides didn't come through right anyway.
Friday is online.
It's not yet, but it will be tonight.